righty then, 7.9. Getting close to the end, kids. Getting close to the ends. Now, luckily for you, you're doing these in 2 weeks. I'm doing these in like a day or two. So 7.9. All of these videos can be found at www.nkinfinity.com. And for Newman, my partner in crime is Vicky Newman. Mr. Krause, you can call me Mr. Key. All right. So let's get some weird stuff done. Now, this warm-up was designed just to mess with you, completely mess with you. We're going to graph all the other trig functions and see how those look. So let's talk about this one. Now, I know it looks weird. Our amplitude is 6. That's weird. Our b value is pi over 6. That's weird. Now, our period is going to be 2 pi divided by pi over 6. Well, that's weird. So let's see what that looks like. 2 pi over 1. Now we're dividing by a fraction, so we flip and multiply. 6 over pi. So those pi's cancel. This is just 12. That's weird. That means it's going to take 12 to finish one full curve. Our x scale would be period 12 divided by 4, which is just 3. That means every 3 is an important point. Our value here is -2. Our min is -2 minus 6, which is equal to -8. And our max is -2 plus 6, which is 4. So let's see. How should I set up my graph? And before I start, that's why I didn't put any axes on here. I want you to think about, how do I have to set up my graph? What is this thing going to be looking like? So normally I would go between 0 and 2 pi. But in this case, I'm going to finish, and this is really weird, I'm going to finish at 12. So I want my x value, or my domain, to go from 0 to 12. Now the range normally would go from like -1 to 1. But in this case, what's my minimum value? My minimum value is -8. So I'm going to go from -8 to a maximum value of 4. So I need to have at least that set up on my graph. Now, unfortunately, there's like 0 shot of me making this look nice. It's not bad. Now, since I need more negative than positive, I only need 4 on the positive end, so I'm going to go down about 6. And put my x-axis there. So this is different than anything you've seen before. So we need to make our x scale every 3. So 1, 2, 3. 6, 9, and 12. That's not bad. 3. This will be 1, 2, -1, -2, -3, -4, -4, -5, -6, -7, -8. And I need to get up to 4, so 3 and 4. All right. Whew, there it is. Now, first thing we're going to graph is our midlines. I'm going to put my midline in maybe in green because it's just to be able to see it. My midline's at -2. Now be careful here. This is a sine function. A sine function, let's go in light blue. A sine function starts at a minimum, starts at a 0. It ends at a 0. Remember, this is 12. And in the middle is a 0. So starts at a 0, ends at a 0, in the middle is 0. This is a sine curve. In between those, so this is 6 and this is 9. At 3 and 9, we're going to have mins and maxes. At 3, we're going to have a max. Now we're going up because this doesn't have a reflection in there, so we're going to go up to 6. And then we're going to go down to 9 or 8, -8. So at 9, we're going to go down to -8, and there's my graph. Now it still looks like a sine curve. Oops. it still looks like a sine curve, but the scale's all messed up. It's not like a radian scale. It's a, you know, it's a weird scale, but it still can be graphed, and it still looks like a trig function. Let me graph it in black so you can actually see it. And there it is. All right, kids, that's it. Oh. Let's do another one. What? I don't have any prompts? I don't have any prompts. I need my prompts. I need my stuff. Okay, let's see if we can do this without my prompts and my stuff. So let's talk about amplitude. Oops. I was going to change that to red. Let's talk about amplitude. My amplitude is, we'll just go order. Amplitude is equal to 3. My B value, or my B value is pi over 3. Now to find my period, I take 2 pi and divide it by my B value, which is pi over 3. And if I do this, it's 2 pi over 1 times 3 over pi. Remember, multiply by the reciprocal. I get 6. Okay. It means my x scale is going to be 6 over 4. That's 1.5. Well, that's really strange. What am I going to do that for? All right. My C value is 4. My min will be equal to 4 minus 3, which is 1. And my max will be 4 plus 3, which is 7. All right, I think we're ready. I really don't even need anything on the negative end, so I'm just going to put my axes down here somewhere. It doesn't have to be in the middle, kids. Don't always get caught up in the fact that you have to put in the middle. All right, and let me put my scale on here. I'll do this in a different color. I got to get up to, what, 7? So 2, 4, 6, 8, 10, and just for fun, -2. So every 1.5, I don't like these things. So you know what I'm going to do? I'm going to do this. I'm going to do something a little crazy, a little funky. I'm going to say this is 1.5. I'm going to say this is 3. I'm just going to count by 1.5s. This is 4.5. And that's 6. That's all I need. Now remember, I need 5 points. What difference does it make where I say every 3 boxes is 1.5? That makes every box a half. And that's okay. I can do that. Every box is a half. That's not a problem. I can do that scale. All I need to do is make a scale by 1.5s on these crazy graphs. Okay. Let's get our midline in there. Let's do midline in green again, just for fun, so you can see it on this weird graph. Midline is 4. So we're going to put our midline in. Okay. And let's graph this sucker. Now, this is a cosine curve. It starts at a max. It ends at a max. In between is a min. So our max is 7. So we're going to start at 7. At 6 here, we're going to end at 7. And in between those two, we're going to go to a min, which is 1. Now, in between those, at these very important points, 1.5 and 4.5, we're going to have zeros. There she is. Yes, that was actually really good. That was gorgeous. Man, I get excited about this stuff. Not really. I'm just kidding. I'm pretending. I'm pretending. All right, when you're graphing your trigonometric function calculator, whenever you're talking about your calculator, you got to make sure that you're in radian mode. You see this up here? Radian mode. We need to be in radians. So, following these directions, go to the graph and press graph mode. Change the view by clicking the min, max, x values. So what we're going to do is go into graph mode. Now, do you see this right here? We don't need this. See, we're in radian mode, which is good. See, I can hover over that. But this is useless. So what I want to put over here is negative 2 times pi. And then I'm going to press my tab button. And let's make this 4. Doesn't really matter. Tab. This one should be 2 times pi. Now notice it's converting it to 6.28. That should come as no surprise to any of you, because pi is 3.14, so negative 2 pi would be 6.28. We're also going to want to change our table settings. So Control T, Control T. Oh, I don't have a graph in there. I'll have to do that in a minute. So, we're going to graph tangent. So let's graph. Tab, tangent. So tangent of x. We're going to see finally what tangent looks like, and hit enter. Now if you don't see this, it's because you're not in radian measure. Now, in order to graph this thing, it's probably in our best interest to take a look at the table. And we're going to go to Menu, Table, Edit Table Settings. And we don't want to step by ones because that's not how we graph. We graph in terms of radians. So why don't we change this to pi divided by 2. Now you're going to see some really weird number in there. All right. See 3.14159. These are ugly. Now, let's go back. Let's take a look. I know we changed our table setting, but whatever. Control T. Let's take a look at this thing. Now, you'll notice, as if you take a look at it here, notice this is growing up and up, and it's getting closer and closer to this point right here, which is an asymptote. Now, where is tangent undefined? Tangent is, remember, tangent is really, sine of x divided by cosine of x. So whenever cosine equals 0, this thing is undefined or has asymptotes. Well, that means, let's see, cosine is 0 up and down, right? Because there's no left or right movement. So if I go up at 90 or down at 270, so at plus or minus pi over 2, or plus or minus 3 pi over 2. Now let me graph those lines. I think I can graph them. Let's see if this thing lets me. Delete. Now this will let me graph the relation x equals pi divided by 2. Now if I graph that, there's that line right there. See it? I graphed the relation pi 2 right there. That's the relation. Notice it's a asymptote. I can graph the negative of that. Tab. I can graph x equals negative pi divided by 2. There's another one. Let me hit tab. How about 3 pi over 2? X equals 3 times pi divided by 2. Divided by 2. Okay, and there's the other asymptote. So, and then the last one would be out here, tab, at x equals negative 3, negative 3 times pi divided by 2. And there it is. So those are my asymptotes. So you need to have those, or you need to understand those as far as when we're graphing, because those will become your important points. Pi over 2 and negative pi over 2 are your important asymptotes. And we'll graph those when we graph this thing. So what is the domain? Well, the domain for this one is going to be, it's really from negative infinity to positive infinity. However, we can't include the multiples of pi over 2. So state the domain and range for this. So the domain and range, what we're going to really is from negative pi over 2 to pi over 2. And the range is from negative infinity to pi over positive infinity. So the domain is all reals except x cannot equal plus or minus pi over 2. Actually, and then I can go plus or minus negative 3 pi over 2, or I can go plus or minus 5 pi over 2, or plus or minus 7 pi over 2. So really it's odd pi over 2s, which is really kind of weird as far as the domain goes. So what we're going to do is we're going to sketch our asymptotes first. And we've already talked about what our asymptotes are. Our asymptotes are at pi over 2, at negative pi over 2, at 3 pi over 2, at pi over 2, and at positive 3 pi over 2. And that looks like a drunken sailor to that. That's craziness. All right, so those are our asymptotes. So now what does it look like? Well, here it's going to go through the origin, and then it's going to asymptotically get closer to that point. Notice it's got a little curve and a bend in it, all right? So that's what we're going to graph. Through the origin, and it's going to graph like this. And through the origin, and it's going to graph like this. Here, got another one. Right here at pi. Right here at pi, we're going to go towards it and towards it. So we're going to get closer to it and closer to it. Again here. And then this is the weird part. At 2 pi, right here at the end, we're going to get closer, but we're not going to go past it. So we're going to go point here and get closer. And then we're going to get a point here, and we're going to get closer here. And I probably should have done those. I'm going to do those in a thicker color. So here's what it looks like. Notice it's got that bend. If you draw a straight line, it will not be good for you. If you cross the asymptotes, it will not be good for you. All right, there it is. So that's the tangent function. Not a problem. A little weird, but not a problem. It's just a different kind of function. But remember, because you had all those undefined points. Now, don't forget, cotangent's also undefined. Maybe we'll take a look at that someday. All right, so we got to graph three more functions. Now we're going to graph cosecant of x. So graph cosecant of x. So what I'm going to go back to my calculator. Get rid of this. I'm going to go back to my calculator, and I'm not going to save this. And I'm going to go back in, and I got it. And I'll probably set that back up. Negative 2 pi tab 4 tab 2. There's a faster way to get pi tab negative 4. So I got that sucker set up, ready to go. And let's just take a look. I'm in radian mode. Let's just take a look to see what this thing looks like. So we'll hit tab, and we're going to graph cosecant x. Now this is going to look really funky. Ooh la la. Crazy. And I'm going to show you something about that in a second. But what is cosecant? Cosecant, if you remember, is 1 over sine of x. So cosecant will be undefined wherever sine is equal to 0. So wherever sine is equal to 0 are where we're going to have asymptotes. And those are going to be at plus and minus. Now where does sine equal 0? Sine equals 0 at 0 Oh, I was looking at the wrong one. Sine equals at 0 and at pi and at 2 pi. Wait, but I got to go plus or minus pi and plus or minus 2 pi. Now, plus or minus 2 pi, that's going to be origin, or 0. But we're going to graph. So we have asymptotes at those. Now, because I got to use the x-axis, let's go to asymptotes. We're going to do our asymptotes in dark black. So asymptote here, and asymptote at pi, and at negative 2 pi, and at pi, and at 2 pi. So those are our asymptotes. All right, so where am I going to graph this thing? What am I going to do? Well, what happens at pi over 2? What is the sine of pi over 2? Or the sine of 90 degrees? Isn't that equal to 1? So then wouldn't the cosecant of pi over 2 also be equal to 1? And if I take a look at the graph and I go to pi over 2, which is right about here, and I go up, oh, look, it's at 1. So here it's going to be 1. Let me graph this in red. And at 1, and it's going to go up asymptotically. At 3 pi over 2, sine is negative 1, so it's going to go through that point, but it's going to go down. And over here, same thing. Now, really all you got to do is use your graphing tool to graph to make sure that it kind of looks like this. We spent a lot more time on this in the past, but that's that. Now, how can I tell just from a graph whether or not it's cosecant or secant? Now, the coolest thing ever is this. If I graph the sine function, which starts at a 0, ends at a 0, has a 0 in between, it's going to look like this. So you'll notice that the cosecant, which is the reciprocal function of sine, kind of rides on the bumps of the sine curve. Notice they have this. They ride on all the bumps of the sine curve. So if I was to come over here and graph, and I hit tab, graph sine x, it would hit all those points. So it rides on the bumps of all the sine curves. It's the easiest way to do it. Do I have any other questions? The range is negative infinity to positive infinity. The domain is kind of a pain because domain is all reals except multiples of pi. Really, that's what it is, except for the multiples of pi. All right. Let's talk about secant. I bet you got an idea about secant. Now, let's see. Secant is really 1 over cosine of x. So wherever cosine of x is, that's where it's undefined. So that's where we're going to have our asymptotes. Well, we've already done this. It's the same asymptotes as it is for tangent. Plus and minus pi over 2, plus and minus 3 pi over 2. And every odd multiple of pi over 2, which makes the domain really hard to write. It's really negative infinity to positive infinity, except the odd multiples of pi over 2. I don't even know how you write that, the odd multiples of pi over 2. The odd multiples would be 2n plus 1. You know, the actual answer would be x is in a set of all reals such that x cannot equal 2n plus 1 pi over 2, where n is the set of all integers. Now, who in the world in their right mind is going to, well, why 2n plus 1? That stands for all odd numbers. 2n plus 1 is always odd, divided by 2. Nobody's going to write that. So that's the actual domain for this. But nobody's going to do that. Negative infinity, positive infinity for the range. No, this is not even true. Why did I write negative infinity to positive? I think I wrote negative infinity to positive. No, I didn't. Thank goodness. The range here is from negative infinity to negative 1. including, or from 1 to positive infinity. And that same is going to be true for this one. It's from negative infinity to negative 1, inclusive, union 1 to positive infinity. All right, so let's take a look and see how this one works. Asymptotes first. We're going to draw in our asymptotes. I think I was pressing a button, so that's why I did that. Asymptotes. Pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2. And at 0, cosine is 1. So let's get a look and make sure we got a picture of what this is going to look like. Oops, let's go to our graphing calculator. It's going to look a lot like this function, except, let me go through and delete these. Control tab. And then hit the up arrow. And then we're going to change this to secant x. It's going to look a lot like the other one, except they're going to shift. And we're going to have new asymptotes. There they are. And our asymptotes run right here at pi over 2 and negative pi over 2 and at 3 pi over 2. So at 1, it's going to look like this, and it's going to grow asymptotically towards the lines of asymptotes. At these two, come down, come down. At this one down here, down. Oops, that's terrible. Don't do that. That looks like a line, and I would take off points for that. It's just really hard to do it. Oh, so much easier on pencil and paper for these. And then here is a point. So from here, it's going to look a lot like this, but go to the left. Make sure you look at your graph. It's kind of like these two pieces together make up one. Let's go look at our table. Oh, yeah, look, see, to the right, to the left. We got 3 normal humps and then off to the left and right. Okay, we got it. That's it. That's cosecant. That's what the cosecant function is. Now, again, just like before, if I press, this is secant, by the way. If I press tab and I graph cosine, cosine x rides, or secant rides right along. So the red one and the blue one, the blue secant function rides along the bumps of the cosine curve. So again, if I gave you a curve and you said, oh, I don't know which one that is, draw it in. Oh, it starts at a max, ends at a max, min in between. That's the cosine curve. So this has to be secant because it's riding on top of it. All right, we got one left, and that is our favorite cotangent. All right, much like tangent, cotangent also has, and all of these have asymptotes because they all have a denominator. So this is cosine x over sine x. So wherever sine x equals 0, we have asymptotes. So those were the same as cosecant, right? Do you remember cosecant? Cosecant had asymptotes at 0, plus and minus pi, plus and minus 2 pi. So I have an asymptote here. Draw the asymptotes in first. Asymptotes at pi and at 2 pi and at negative pi and negative 2 pi. I feel like I'm saying Tupac. All right, draw our asymptotes in. Now we go over to our calculator and let's just take a look at this. You're going to see that it looks a lot like the tangent curve, except not. So make sure you understand the difference between the two. So let's press tab, hit the up arrow, delete this one. Oops, just go to equals where we got escape. Hit the up arrow, and we'll delete this one, and we're going to type in cotangent of x. And hit enter. So it kind of looks like the tangent curve, but it's coming down, not up. Tangent goes up, cotangent comes down. So, again, at these in-between points, they're going to be our zeros. Let's graph it in black. They're going to be our zeros. But instead of going up, cotangent comes down. So it comes down like this, and asymptotes. Comes down like this, and then asymptotes. Don't draw a straight line, you'll get in trouble. Asymptotically. And there's our tangent. There's our cotangent curve. Okay? There it is. You know, and again, I'm going to show you what the tangent. Let me hit the tab button, and I'll hit tangent, just to show you what the tangent of x looks like as a heads up. Tangents go in the other directions, cotangents go in the other directions, okay? But they have asymptotes. And all of these functions that I've graphed now have asymptotes. All right, so ready to graph a new one. What do we got left? More about tangent. So so I'm asking for the domain of tangent. Again, it's really difficult to do. Where is tangent undefined? Tangent is equal to sine over cosine. So once again, tangent, the x is in the set of all reals, but x cannot equal, and again, it's 2n plus 1 pi over 2, where n is in the set of all integers. And I know that looks really funky. But x can't equal all odd multiples of pi over 2. So negative pi over 2 is an asymptote. 3 pi over 2, negative 3 pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. Range is easy. Oops, excuse me. Range is just negative infinity to positive infinity. The equations of our asymptote is x equals plus n minus pi over 2. X equals plus and minus 3 pi over 2. I can go 5 pi over 2. It's really any odd pi over 2. Is it a function? Yes, it's a function. It passes the horizontal line test. Is it a one-to-one function? Clearly no, unless if I just restrict it to from negative pi over 2 to pi over 2, it's a function. Is it a one-to-one function? No, but we can look at it, if we just look at it in this area right here, if I just look at it between these 2 points, from negative pi over 2 to pi over 2, and I just look at that piece would be a one-to-one function. So the next question I said is, can we look at an interval over which f of inverse, and the answer is yes. Yes, we can, if we look at from negative pi over 2 to pi over 2. Use the graph to determine. All right, so tangent of 90. 90 is pi over 2. That's undefined. How about 180? Well, that would be 0. How about the tangent of 0? That'd be 0. And finally, 3 pi over 2, again, undefined. All right. Now the only thing I didn't graph, and I'm going to show these real quick. I don't think we do these in the next day, but I really wonder what the inverse tangent looks like. Can we graph that, I wonder? So tan inverse of x. Ooh, look at that. Looks like the square root function almost, doesn't it? Tab. I'm going to graph the inverse of sine. Remember what that looked like? Sine inverse. Remember, it's only a small piece because it's only defined over a small piece. Oh, look at that. Remember we only defined it over a small piece the other day? And press tab. We'll do the inverse of cosine. There it is. So those are, you can always use your calculator to figure out which function you're talking about to do inverses. All right, that's it, kids. That's all she wrote for I think this is day 9. Day 9 is over. Hit the subscribe button. Let me know what you think. Hopefully you learned something from me today. Miss Newman and I would love for you to hit that subscribe button. All right, guys, catch you on the flip side.